And we're back. All right, so we already did some overview type stuff for correlation and scatter plots. I wanted to make sure I got a chance to show you some practice on here. This is Alex. This is the homework right here that we would be looking at doing. I'm going to preview it so we can take a quick look at it. There aren't a lot of questions on this thing. In fact, there are only 6. All right, so the first one is about, there's a table. I want you to create a scatter plot. Remember, a scatter plot is just a dot that represents that point. So we'll let the first thing, amount of shrimp in pounds, be the X. See that? And then we'll let the second thing, the amount of beef in pounds, be Y. So I'm going to go through, and I'm not going to do it all because I think you know how to do this, but 3 for X, 9 for Y. So let me make sure I get this in here. Let me make that a little bit bigger. 3, 9, we get a point. The next point is 5, 2. 5, 2. Ooh, missed it. Let me erase that. All right, and you go on and on and on. When you're done, just go ahead and check it. Now, I'm not going to check it because I know I'm not right because I'm not done. All right. Number 2, what is it saying? Fine. All right, for number 2, it's the same thing. Create a scatter plot. Not that big of a deal. For number 3, all right, the scatter plot shows the time spent texting and the time spent exercising for 25 students last week. Also shown is the line of best fit for the data. It's one thing I didn't say in class because the line of best fit, in the other video I should say, because the line of best fit is not necessarily something that we're going to do with correlation, but it helps you to figure out exactly what it is, what kind of relationship you have. So you see in the background, we have the scatter plot, all the different points. If I were to fit a line that goes through the center of all that data, like you have this line right here, that is what we would call the line of best fit. That can be calculated mathematically as well. It's a little bit involved. It would not be one of the things that I would teach you even if we were in class. It would be something that we would use Desmos for. But just as a visual, just like you can calculate the correlation coefficient, you could calculate this line of best fit. Or you could just look at it as a visual. This is roughly the best fit of all the data here. If I drew a line through the center, it's going to give me roughly the center of the data. Now that thing can be used to make predictions out of it. So if I were to look at, say, 5 hours of texting, the question would be, how much time would we have with that? Well, if I were to predict it based on this data, how much time would I expect to spend exercising? Well, if I go up to the line, because that's the line of best fit, I would see that I would expect there to be 5 hours of exercising also. Similarly, if I looked at 9 hours texting, that's my input, how much time would I expect to see in this situation on time exercising? Well, I would just go up to this line, and I see that the line crosses at 2. So I can make predictions from this line of best fit. That is not the same as a correlation. A correlation is the relationship. So let's look at these questions here. For A, for these 25 students, as the time spent texting increases, the time spent exercising tends to what? Well, looking at the data, since it's kind of going down, the more time I spend texting, the less time I spend exercising. It's a negative relationship. That means if I were to look at this, if I go up on one, I'm expecting to go down on the other. That's just the basic idea of lines, in this case with a negative relationship. Let's look at part B. For these 25 students, there is a blank correlation between the time spent texting and the time spent exercising. I'm looking for either positive, negative, or no correlation, no relationship. Well, again, we've already established that that is negative. Now, if I were to use a line of best fit to predict, that's the key here. You don't predict from the scatter plot, but you can predict from the line of best fit. That a student texting for 4 hours would exercise approximately how many hours? Well, if you texted for 4 and I went up to the line of best fit, I'm expecting there to be somewhere around 6. It may not be exactly 6, but let's just see what it says. 5.8 is probably better. Let me see. If we said 4 hours, the line is just below the 6. You can see that. So I would probably go with 5.8. All right. And then once that gets out the way, I can check it. We should be good. Okay. Number 4, I think, is just like that. I think we can do this kind of quickly. Given that information, it's talking about hours worked and the money spent. Hours worked, money spent. If I work more hours, I'm expecting to spend more money because you'll have more money, I guess, to spend. All right. My line of best fit kind of fits right in the middle. I see my correlation is kind of tight around the line. So if I had to give a number, it would be a number close to +1. That's not what it's asking here, but I wanted to throw that in there. Now, for these 21 students, as the number of hours increased, the amount of money spent also increases. Now, for these 21 students, there is a what kind of relationship? If one increases and the other one increases, that makes it a positive correlation, a positive relationship. And if I were to use the line of best fit to make a prediction for a student working 10 hours, I would expect that person to spend about $25. Let's see what the options are. Oh, 25 is one of them. Check it. Done. Now for questions 5 and 6, giving you different scatter plots. 5 and 6 would be the same. In fact, it says shown below are the scatter plots for 4 different data sets. Answer the questions that follow. The same response may be the correct answer for more than one question, so you might say it more than once. Now, before I answer these questions, I want to look at these things here. This is a negative relationship, and it's close to a line, and so that's going to be a strong negative. This one is all scattered all over the place. I can't see a general positive or a general negative relationship. That's going to have a weak correlation. Okay, this strong one would be, since it's negative, it would be close to -1, but not, I say more than that, but you know what I mean. Close to -1. This one can't be close to 1, it can't be close to -1 because it's not close to a line. Figure 3 looks like a positive relationship. It looks like a really close line. If I were to draw the line of best fit, I would try to fit it in between there. Those points are all close to it, so that's going to be close to a +1. This one is also generally in a linear pattern. It's not as tight as this one. So my R would not be as close to -1 as this one. So if I call this -0.9, I might call this -0.8 or something like that. It's still negative though. So with that said, let me take a look at these questions. Number 1, for which data set is the correlation coefficient R closest to 0? Closest to 0 means furthest away from a line. That would be this one, figure 2. Number 2, which data set indicates the strongest negative linear relationship between its two variables? The strongest negative linear relationship. Well, that's negative, that's negative. The one that's strongest is the one that looks closer to a regular line. I would say in this case, figure 1. And for which data set is the correlation coefficient closest to +1? Well, that's close to -1. That's not close to either of them. That's close to 0. This is close to +1, and that's negative, so that's not the case. I would say figure 3. There we go. Same thing for number 6. I think it's the same kind of question. I'm not going to do it, but let me confirm that it is, and it is. And we're done.